All right, so today is chapter 5.7. It's called Further Transcendental Functions. Transcendental functions being sines and cosines and whatnot. So we already know, and inverse sines and e to the x and so forth. So from whence did this fella come? Of course, he came from negative cosine plus c, col. And this fella came from, of course, from sine. Let's see, we know that. And we know the antiderivative of e to the x is just e to the x, right? And we know this one. Don't let it freak you out. Mr. Grimm used t. So what? Oops, darn it. So what he did? The answer is just ln of t plus a constant, right? So we've done all those ones, okay? No big deal there. Now, what would happen, though, if I wanted to take the antiderivative of b to the x? Oh, I don't know, Mr. Groom. Before you answer, let's think about this. Do you recall, back in the day, we said, let's take the derivative of y equals b to the x? I think you do. Remember we took the ln of both sides? So take the derivative. Remember that's the implicit differentiation, so that's 1 over y dy dx, right, is equal to ln of b. Remember that? Because that's a constant. The derivative of x goes away. So then the derivative, so dy dx is equal to y times the ln of b, yes? Or in other words, b to the x times the ln of b. Does that make sense? So friends, where did this fella come from? Well, clearly he came from b to the x, yes. But if it had been just b to the x, there'd be an ln of b here. So look what we're short. We're short an ln of b plus c. Okay? Now think about that. If you take the derivative of the constant, it goes away, obviously, right? What's the derivative of b to the x? The derivative of b to the x is that. So you'd get b to the x, ln of b, over the ln of b, yes? You're done. So this right here is the answer. So the question would be something like this on the homework. Hey, Mr. Graham, let's take the integral of 3 to the x from 2 to 4. Okay, cool. So the answer is going to be 3 to the x over the 3 to the x over the ln of 3 from 2 to 4, yes? So that's going to be 81 over the ln of 3 minus 9 over the ln of 3, whatever that is. That's my answer, which of course is 72 over the ln of 3, which I still don't know what that is. So let's use the calculator. So 72, come on. Oh, you hippie. Oh, crap. Now I shut it off. Darn it. Okay, this is a lot harder when you people are not here, because I can pick on people. Cora, Sophie. Come on, Daniel, pay attention, for God's sakes. 72 divided by the ln of 3. And diamond, enter. Heck, we even pick on Lacey if we want to, 65.5. All right, there we go. Boom, that would be my answer. But the idea is I need to know the antiderivative, and it's that guy right there. Okay, no, that's not too difficult. All right, then, well, let's just go see what else we know. We mentioned yesterday in class, I mentioned to you this. If you saw this guy in a dark alley, you know that the antiderivative is arctan of x plus c. But how do we know that? Well, we know that because back in the day we said y is the arctan of x. And if I want to take the derivative, of course, what do? I take the tangent of y is equal to, right, x. And so the derivative would be so the derivative of tangent of y is secant squared of y dy dx is equal to 1, right? So then you're like, okay, well, dy dx is equal to 1 over the secant squared of y, which is really just the cosine squared of y, right? Because 1 over secant is cosine. Well, what does that mean? Well, remember this triangle, we said the tangent of y is x over 1. That means the hippopotamus is 1 plus x squared, square rooticated, yes? So then the cosine would be the adjacent over the hypotenuse squared, right? That's where we got that from. So in other words, this is the derivative of arctan. Therefore, the antiderivative of this better be arctan. Well, can we do the same thing for sines and cosines? And I will do those two briefly. Then I'll just show you the other ones. What you should know is this. When you see one of them, you should go, I remember you. Yeah, you're that fella, right? Because those are the ones that should stick in your memory banks. When you see them, you should be like, oh yeah, that's that guy. But you can't necessarily remember their names. You just maybe know that, oh, that's a teacher or whatever, okay? Or that's, I saw her at a concert, or whatever it is, okay? You should be able to visualize them. So this one here comes to mind. God, worthless computer, quit shutting off. dx, okay? And you're like, well, what is that, Jay? Well, just a cotton picking minute. Suppose we start with this fella. And we write it this way. I don't remember if it's cosine or sine, to be honest with you. I guess we'll find out and be surprised together, okay? It's been a while. The derivative of cosine, of course, is negative. Oh, darn it, it's actually sine. Sorry, Sophie. Get off my back. Jeez. The derivative of sine is cosine of y, dy dx. Good morning, Quinlan. Equal 1, dy dx, 1 over cosine. Right? Well, remember, this is your relationship. So the sine of y is x over 1. Means that's that, yes? So what is the cosine of this guy? Well, the cosine would be this over that, right? Well, I'm flipping it over, so it's going to be 1 over that. You see this? So this is the derivative of this. Therefore, this becomes arc sine of x plus c. Okay? The cosine one would be the same, except there'd be a negative on top. Okay? That's the only difference on that one. And let's do one more. I don't remember how this one looks, so let's just try it this way for fun. The secant, the arc secant. Suppose you had this. Remember, that means the secant of y is equal to x. The derivative of secant is secant tangent dy dx. So dy dx is equal to, well, if you divide over to here, you're going to get cosine and then cotangent, right? And the relationship is this. Secant is x, so that's that over that, right? I feel like. True? Does that make sense? Do you see it? Secant is hypotenuse over adjacent. So I want the cosine, so that's 1 over x, times the cotangent would be 1 over squirt x squared minus 1. And you end up with this thing right here. And I'll write it like this. And then I want to go look at the graph for a minute, because there's one thing we need to take care of, okay? So think about this for a minute. If you were to go to, if I can find my stupid, oh, wait, there it is. I found it. Oh, Desmos, where art thou? So if you go to inverse secant of x, it looks like this. Notice that it's always an increasing function. Do you notice that? That's kind of important. Meaning that no matter where I am, the function is always increasing. Now let's put in our supposed derivative, right? So our supposed derivative is this times the square root of this squared minus 1. Uh-oh. Look what happened. Over here we've got positive, in the positive side of things we've got a positive slope, but on the negative side we get a negative slope. So to fix that, what we're going to do is we're going to put right there, we're going to go absolute value, if I can find the dumb thing. Bam. Ah, mucho better, senor. Now, so what that means is, over here, somewhere, this should have been this. You see that? So what does that mean to me? It means that when I see this guy, that means it's going to be the arc secant of x plus c. Okay, the rest of those are for your viewing pleasure on page 336 in the text. Okay, they're all there. Inverse secant, inverse cosine, inverse all of them. Okay? Now, I'm going to do a couple more here today before I go, and we'll kind of see where we end up here as we get going. I want to do that one. So here's an example of one that you will see. It's similar to the one I showed you yesterday. Well, actually today, because it's still today when I'm talking to you. Okay? But tomorrow will be tomorrow, and that's life. 4t squared plus 9. Okay? Now, clearly this has to be an arctangent. There's two reasons I know that. What's on top? Just the 1's on top. Are you with me? If there was a t on top, I could use substitution, but it's arctangent. I know it's tangent and not secant, or it's not cosine or secant or any of those because there's no square root in the bottom. It's just that. However, remember it's got to be 1 plus something squared. Okay, well I don't have that. That means this value right near needs to be a 1. So how to do that is I'm going to factor out, okay, I'm going to factor out a 9 out of those two bottom guys. So it's going to be 4/9 t squared plus 1, okay, dt. And I'm going to continue factoring that 9 all the way out because it's just a constant. Get it out of your hair. Okay? Now, we're getting close now. So here's my question to you. Oops. Darn it. 4/9. Stop it. 4/9 t squared plus 1. Now, I need to rewrite this as something squared. You see this? So what would that be? Well, it would be 2. So I'm going to replace this with u equals 2/3 t. So then du would be equal to 2/3 dt. Are you with me? Well, that means I have 3/2 of a du is equal to a dt. Is that correct? So what I'm going to do is pull, I still have the 1/9 out front. I'm going to put my 3/2 out there with it. I'm going to get rid of the 0 and the 4 for right now just because I don't necessarily maybe feel like doing anything with them. We'll see in a minute. I don't know if I feel like it or not. And then this is going to be u squared plus 1 du. So that's going to be 1/6. And this is going to be then arctan of u, correct? Which then I'm going to resubstitute and do 1/6 arctan of 2/3 t. Does that make sense? And then we evaluate it from 0 to 4. And so it's going to be 1/6 arctan, this is arctan, stupid, arctan of, that'd be 8/3, I guess, minus 1/6 arctan of 0. Again, make sure that you are in radians before you get carried away on this. You could use, actually, let's go use this model, the good behavior. Let's use 1 divided by 6 arctan of 2/3, good grief, oh shoot, what just happened? Q. And then I could just plug in my values, right? So 4.2, and 0, 0. So 0.2, my answer is simply 0.2. 02, I think is what it was. Okay? Not very difficult. Mr. Graham, I don't know if that seems reasonable or not. Could you show us how you think that might be reasonable? Yeah, I feel like it. So it's the arctangent of, no, it's not either the arctangent, you idiot. Try again. 1 divided by, it's 9 plus 4x squared, right? And I'm interested between 0 and 2. Is that correct? Well, between 0 and 2, how much area is under this curve? Boy, not much. So would you buy that it was 0.2? Yeah, I'd probably buy it was 0.2. Yeah, it sounds reasonable to me. Okay. One of these ones might show up. This is a nice easy one. Okay. Again, this needs to be a 1. A lot of people will screw this up. They're like, I don't know what to do. Well, first things first, friends. So let's factor that out. So let's leave this as x plus 5. Of course, there's a dx here. I got a little carried away. I'm sorry. 4, that's 1/4 x squared plus 1, correct? Right, sure it is. So let's pull the 1/4 all the way out front. That's nice. And then some people will get all weirded out by this. And they're like, well, I don't know what to do. But here's what we're going to do, friends. We're going to break this into 2 separate problems. And honestly, we could have broken into 2 separate problems right from the get-go. And I'll kind of go back and show that in a minute. Now, why can you do this, Mr. Groom? Well, for a variety of reasons, but the biggest reason is because why? What do we always say? Derivatives are, they are too, but integrals are limits. And so the limit of the sum is the sum of the limits. This guy here, oh, and then I screwed this up. That one should have been that one. This one I could have left alone. I'm sorry, don't get mad at me. Geez, Seppa, don't be mean. Now, I feel like this one is an arctangent. So it's going to be 5/4, obviously, arctangent of, okay, but what's going to happen here? You need to let u equal 1/2 of an x. Du then is equal to 1/2 of a dx, yes? So I have 2 du's is equal to a dx, correct? So I'm going to have, this 5 comes out front, so 5/4 times 2 from right here, yes? Du, and then of course it's 1/u squared plus 1. So that's going to be 5/2 arctangent of 1/2 of an x, yes? Now this piece here is a little different because here you notice that there's an x on top. So let's let the bottom be our u, plus 1, and du would be equal to 1/2 of an x dx, right? Well, I don't have 1/2 of an x dx, so I have 2 du's is equal to an x dx. And I'm going to replace these guys with 2, and there's still a quarter out front. And then it's what? It's 1/u du. So it's going to be 1/2 ln of u, which is 1/4 x squared plus 1 plus that business. Okay? Let's see, what's another good one here? I feel like that's gross, Mr. Groom. Yeah, let's do that one. That sounds good and ugly and disgusting. Actually, I don't want to do that one. Actually, I do want to do that one. That one does sound kind of fun. This one will freak a lot of people out. Oh, shoot. From 1 to square root of 3. Okay? Now, some people are like, oh, let's break it into 2 pieces. No. No. Focus your eyes on this. Suppose I just covered up, suppose I just got rid of this piece right here for a minute. You with me? And maybe I move this out front, or out back, I mean, and made it look like that. Can you see how this function now looks like 1 over a function? Yeah. So what if I let u equal arctangent of x? Are you with me? What would du equal? It would equal 1 over 1 plus x squared dx. Wait a minute. That's literally what we had. Look, 1 over this garbage times dx. Shut up. Do you mean to tell me I can replace this garbage here, you see it, with just du? That's right. And then this is 1 over this, which is just 1 over u, correct? Well then, so then it's just the ln of u, Mr. Groom? That's correct. That's totes correct. So then, well, wait a minute then. Well, that's weird, I feel like. Remember the other day I told you you could plug these fellers in over into here and get u values out? What is the arctangent of square root of 3? Turns out it's pi over 3. Mr. Grimm, you just know that? Yeah, I do. And what is the arctan of 1? Turns out it's pi over 4. So I could have done it here, or I could have just resubstituted. I'm going to do it this way this time, if you don't mind. I don't really care if you do anyways. I'm the boss. So it's going to be the ln of pi over 3 minus the ln of pi over 4. That's my answer, whatever that comes out to be. And it's not that bad. Again, don't be panicked. Don't be panicked. Guy, worthless computer. Keeps trying to shut off on me. Yeah. How about, yeah, how about that one? Yeah. Oops, already got a dx, dummy. Hey, what does that look like, Mr. Grimm? That looks an awful like arc cosine or something, or arc sine, yes? Except that it would need to be 1 minus x squared. You see that? In other words, I need to have this be something squared. Well, Jiminy crickets. What on earth squared is equal to 16? Well, 4, obviously. So if u is 4x, then du would be equal to 4 dx, correct? Well, that's a quarter of what I have. So I'm going to replace that with a quarter of a du. And that's going to be 1 minus u squared, square root-icated, yes? Well, Mr. Grimm, isn't that just arc sine? It is just arc sine of u, which is 4x. And you're done. Okay? I can feel like I can do a lot more examples this way because people aren't crying about, you're going too fast, Mr. Grimm. I know, I'm a horrible person. I'll probably get over it, though. I'm just teasing, don't be mad. Jiminy Christmas. I feel like, ooh, that sounds like a fun one. Check this one out. Check it out, yo. The integral of course, dx, and you're like, wait, then check it out, 5 to the 2x plus 1. Is that what it is? Oh, minus 1. Tricky dicky. Now, Mr. Grimm, this is in this section, so it's probs going to be one of those guys in the table. It feels like, to me, it is the most similar to, I can't even read without my glasses on. Okay, well, clearly it's not secant, or it's clearly not arc secant, yes? Okay, it's clearly not that, because there's no x out in front of the thing, yes? You're like, it feels kind of like arc sine, Mr. Groom. Well, you kind of, but not quite. So is there something that's a little weird about this problem? Yeah, a little bit weird. Let's see if we can figure out, which way we could go about it. Now, before you get carried away, or before you get freaked out by it at all in any way, shape, or form, let's think about this for a minute. What does 5 to the 2x really look like? I feel like that's really just 5 to the x squared. Does that make sense? 5 to the x squared. Well, that's kind of cool. All right. So then, how on earth would we go about integrating that beast? In other words, how would we go about it? So that looks an awful lot like x squared minus 1. And so, any ideas? Think about that for a minute for yourselves while I think around here. I'm trying to do two things at one time. I'm not good at that. I don't know about you. You guys probably are, but I kind of stink at it. It's just weird. I don't like it. Not good at it. Uh-huh. Sure. Sure. Right? Any ideas, any thoughts about how to go about it? I feel like... Well, somebody might say, well, we could let u equal 5 to the x, which I totally agree with. And if I did that, then I'd get, what would I get? I'd get du is equal to 5 to the x ln of 5, right? dx. That's interesting. And so, hold that thought a minute. I'm not done yet. Then let's divide that over here. So I got 1 over ln of 5 du is equal to 5 to the x dx, yes? Now, there's a problem with that. Do you see a 5 to the x anywhere? No, I don't either. So I'm going to have to stop and think about this one for a minute. I picked a problem that's kind of tricky. Mr. Groom's got to see if he can outwit the computer here a little bit or something. See if I can do it. All right, hold that thought a minute. I got another stupid thing to do. Come on. One moment, please. All right, I'm back. Okay, let's tweak this out. Let's go back and look at this. We don't have any that are like this. We have ones that are 1 minus, yes? That means I kind of need to change this guy into a 1. All right, that's easy enough. How do I do that? Well, what I'm going to do is I'm going to factor a 5 to the 2x out of both of these cats. And I'm going to be left with 1 minus 5 to the negative 2x. Are you with me? Oops, is that cool? Can you see that? Now, if I pull this outside of the square root, what am I going to get? Well, I'm going to get a 5 to the x squirt 1 minus 5 to the negative 2x dx. Well, that makes me a little happier because up here I was doing the right thing, but what if I made it 5 to the negative x as my u now this time? You with me? So what's that going to give me? Well, it's going to give me, ouch, what's the derivative of 5 to the negative x, do you think? Okay. Do you feel like there should be a negative floating around in there? I feel like there should be. And what would it be? It would be negative 5 to the x, ln of 5 dx. So if you look at this deal right here, oops, I'm going to bring the negative with me. Oops, I'm sorry, and this is 5 to the negative x, yes? Well, what is 5 to the negative x, friends? 5 to the negative x is 1 over 5 to the x dx. Do you see that? So what I see right here, do you see it? Do you see it? It's 1 over 5 to the x dx. Do you see that right there? I'm going to replace it with negative 1 over ln of 5. Are you with me? And I'm going to put a du on top. And then this is going to be 1 minus u squared square root-icated. Yes? And what is that? Well, it's negative 1 over ln of 5. This is arc sine of u. But what is u? U is 5 to the negative x plus c. That's it. That's it. And that's your answer. Okay? You're going to be doing a ton of those. I don't know about a ton. You're going to be doing a lot of those. So we should do a few more here, kind of get the hang of them a little bit more, I feel like. Yeah, like I feel like that guy. I feel like this guy is going to show up. So the squirt, and this is, Okay. Again, this looks an awful lot like, if you look back on page 330, or 336, you will see this looks an awful like arc sine, arc secant, yes? Okay. And as long as x is positive, that's where this thing's going to come from, right? As long as my x's are positive, this will be the correct thing, right? In other words, if x is positive, this will be the same as if it was this, correct? It's a piece of cake. As long as we're over there, we're in good shape. So I feel like, though, feel like this looks very similar, except I have to be careful a little bit. I need to do a u substitution. U is 5x. Du is 5 dx. Well, I don't have that. Right? So I'm going to have a 1/5. But what about that x? What about him? Well, I feel like x is equal to u divided by 5, yes? So if I did u over 5 down here, that would be fine for you, yes? But because it's u over 5 down here, you see it? That's really the same thing as saying 1 over u to the over 5, yes? But that's the same as 5 over u, is that correct? So when I write it like this, it really becomes this, which these guys cancel, don't they? Now, if you think about that, what are you going to end up with? You're going to end up with this thing here. Now, what is this guy? This guy is equal to the arc secant of u, which is 5x plus c. Okay? And that's our answer to that guy. Okay? Forget what problem that is. I was going to tell you what problem that is so you could look it up on your own and see which one I did. Excuse me, that is number 50 on that page of the homework. Number 50. Okay, and yeah, it's pretty straightforward. That's it. Okay? So I feel like I've been rattling along pretty fast. By the time he slows the video down a few times and whatnot, it's probably enough stuff. So I'm going to be done for now. Of course, I'll help you on Monday. Don't freak out. Have a nice weekend. Stay out of trouble. That means you, Soph. Bye.